Hello, this is the video for Chapter 6, Lesson 3 and 4. In this lesson, we're going to be talking about how to solve a system of equations. Previously, we've talked about solving using graphing, and then we also talked about solving using substitution. Today, we're going to learn a new method. What we're going to look at is solving a system using elimination. So if you'd like to pause the video and write this down, basically, the elimination method uses the addition and subtraction properties of equality and the multiplication property of equality, if necessary, to eliminate a variable in a system. So what is this talking about? Basically, what we're going to do is we're going to combine your two equations and see if you can cancel out one of your variables in some way. So looking at example A, if you notice, I've got a negative 6y and a positive 6y. We all know that positive 6 and negative 6 are opposites. If we were to add them together, you would get 0. So we're going to apply this idea, and instead of just adding the negative 6 and the positive 6, we're going to add the entire system. And so I'm basically going to look at them stacked on top of each other, and I'm going to add every single like term. So I have 5x plus 3x, which is 8x, negative 6 plus positive 6, which is 0. So the y's ended up canceling out. Bring the equal sign down. Negative 32 plus 48, which is 16. And then now I can solve for x because I only have one variable to look at. Now x equals 2. Once you've solved for x, the rest is like it. We're just going to pick one of your equations and replace x with what you found and solve for y. So over here, I'm just going to plug in 2. That's 10 minus 6y equals negative 32. Subtract 10 on both sides. Negative 6y is brought down, equals negative 42. Divide by negative 6. Negative 40 divided by negative 6 is positive 7. So the solution, remember, we're always going to write our solution as an xy pair, is 2, 7. Okay, this is the solution. Okay, looking at example B, we see a similar situation. Negative 3 and positive 3 cancel, right, if we add them. So you have to think through what property or what operation is going to allow me to cancel these out. So if I add negative 3 plus positive 3, they will cancel, which means I'm going to add the entire system. So these cancel. I have negative 3y plus negative 4y, which is negative 7y. And bring down the 9 plus 5, which is 14. Divide by negative 7. Y is left over here. And 14 divided by negative 7 is negative 2. Okay, notice this time we eliminated x, which means when we plug in our variable for our equation, and I'm actually going to use the second one because I don't have a negative equation here. So I'm going to write this as 3x minus 4 times negative 2. I'm replacing y with negative 2 because that is what I found down here. So you've just got to be really careful. If you're solving for x, plug it in place of x. If you're solving for y, plug it in place of y. Then I'm going to bring everything else down. 3x minus negative 4 times negative 2 is actually positive 8. So it's going to be plus 8 equals 5, minus 8 on both sides. 5 minus 8 is negative 3. Divide by 3 on both sides. X equals negative 1. So my solution here is an ordered pair of negative 1, negative 2. Okay, so remember, you're bringing your solution together. Okay, what if we are looking at our terms and it doesn't look like I can just add them together. So let's talk about an alternate way to work this out. We can multiply the entire system by negative 1. So if I'm looking at this, if I add x plus x, that becomes 2x. And so, um, and so that doesn't eliminate your x. Now, if I subtract everything, it should, right? It should eliminate it. So one way to look at this subtraction is basically by turning everything into the opposite sign, because that way when we add it, they're going to cancel out. So I'm going to multiply. So I'm going to put multiply by -1 here. And I'm actually going to get rid of this. So you're going to pick one of your equations to multiply by -1, which means every term in here is being multiplied by -1. So x times -1 is -x. Positive 4y times -1 is -4y, -4y. -4 times -1 is +4, okay? So when you do this, basically every single term becomes the opposite sign. And now I have the ability to eliminate my x variables, which if I add them. So if I add the two equations, the x's will eliminate. So I'm just going to do the same thing. Now I'm going to do 10y plus -4y, which is 6y. And then -16 plus 4 is -12. Then I'm going to divide. I'm solving for y here. So y equals -2. Okay. Once you've gotten your y value, you can go back to the original equation or whatever equation you want to look at and plug in what you've just found. So I'm going to use that first one again. I'm going to highlight the one that I use here. So I'm going to use this first equation and substitute -2 in place of y. So I have x plus 4 times -2 equals -4. X minus 8 equals -4. Add 8 on both sides, and x equals 4. So my solution for the set here is 4, -2. That is the solution. All right, looking here, I have the same situation. Basically, I have -3y and -3y. If I can somehow turn one of them into a +3y, when I add the two equations, they will cancel out. So I'm just going to pick one of them to turn into, I guess, multiply by -1 for one of my equations. So I'm going to pick the bottom one because I've got smaller numbers here. And when you multiply this, it basically becomes -2x plus 3y equals -11, because 2x times -1, -2x. -3y times -1, +3y. 11 times -1, -11. And then I'm going to bring the other equation down. So I'm just going to recopy it here so they're stacked on top of each other and add the two. When I add them, I have -2x plus 4 plus 6x, which is 4x. These cancel, bring the equal sign down. -11 plus 27 is +16. Divide by 4, x equals 4. Okay, then substitute in your x value in place of one of the equations. I'm going to pick the second one to replace. 2 times 4 minus 3y equals 11. 8 minus 3y equals 11, minus 8 on both sides. And I have -3y equals 3. Divide by -3, y equals -1. And my solution is 4, -1. Okay, on to the next page. What if you're looking at your systems and there are no terms that have like the same number, okay? So like I don't have like a 3x and a 3x or like a 2y and a 2y. They're all different numbers. So what I could do is basically multiply one of my equations by essentially I'm looking for a common factor. So I'm looking for or a common multiple, to be able to multiply so that one of my terms ends up being the same. So what I'm talking about is if I look at this whole term, I can look at like 2 and 6. 2 is a factor of 6. And honestly, if I multiply 2 by 3, I will get -6. So instead of, because I can't just multiply -2y by 3, I have to multiply everything. So -5 times 3 is -15x. And then -2y times 3 is -6y. 6 times 3 is 18. So what I've done is I've multiplied an entire equation by a number so that one of my terms will be able to cancel. So now when I look at this, positive 6y and -6y can cancel, and I can add these equations to each other in order to cancel. So now we're going to have the same exact method we did earlier. So the only extra step is I had to figure out, is there a number I can multiply by so that one of my terms will cancel out? And here I'm going to look at 3x plus -15x, which is -12x. The 6y's cancel. And then I have 6 plus 18, which is 24. Now I can divide by -12. X equals -2. Okay, now to solve for y, I'm just going to substitute in. So I'm going to pick the second equation. So 3 times -2 plus 6y equals 6. -6 plus 6y equals 6. Add 6 on both sides. 6y equals 12. Divide by 6, y equals 2. So my solution is -2, +2. Okay, what if I'm looking at these and I realize I can't just multiply one of my equations? Like I don't have any common numbers or terms where I can just eliminate and cancel right off the bat. But I can see that just like finding a common denominator, like if I had a denominator where this was 4 and this was 3, I can multiply this by 3 and multiply this by 4 to get like a common denominator of 12. Does that make sense? We're kind of applying this method here. So, or if like 2 and 3, let's say I have a common denominator of 1/2 and 1/3, and I have to add them. I could multiply 1/2 by 3, right, on both sides, and I can multiply 1/3 by 2 on both sides, and I'll have a common denominator of 3/6, right, and 2/6. So, so you've multiplied basically the top and bottom by the same number. Well, what we're going to do here is really just applying the same method that we use to find common denominators, because in this situation, we're not able to just multiply one equation. So I'm gonna use a smaller set of numbers. I have 3 and 2 here. Both are 3y and 2y. I'm going to multiply this top equation by 2, and so I have m for multiply. Then I'm going to multiply the bottom equation by 3. And so when I rewrite this, I'm going to write it over here. 4 times 2 is 8x, plus 3 times y, or 3 times 2 is 6y, and then equals -19 times 2. So we have to multiply every single thing. -19 times 2 is -38. Then I have 3x times 3, which is 9x, and then -2y times 3. And so I'm also being strategic here because I've got a positive and a negative, and I know if I can have them have the same term, if I just add the equations, they'll cancel out. And then -10 times 3, so -30. Now I'm going to add them because I've got opposites already. So when I add, I have 17x. These cancel, equals -68. Divide by 17 on both sides. Let's hope this comes out to be a whole number. And x equals -4. Okay, then Same, you know the drill. Plug x into one of your equations. I'm going to use the second one. 3 times -4 minus 2y equals -10. This would be -12 minus 2y equals -10 plus 12 on both sides. -2y equals +2. Divide by -2, y equals -1. So my solution is -4, -1. Right. Finding the number of solutions. So just a heads up, this is going to be one of those situations where maybe you have all real solutions, all real numbers, or no solution. Okay. So looking at this, is there a way I could eliminate one of my terms? Well, if I'm applying this multiplication, if I could change like 2x to be a -2x, that would work out for me. So if I multiply everything by -2, the equation becomes -2x minus 6y equals -18. And then I'm going to bring down the one that I didn't change, 2x plus 6y equals 18. And then I'm going to add them together. Now notice these cancel, but then -18 cancels as well. So then, and then -6y and +6y cancels. So everything equals 0 and 0 equals 0. Well, is 0 actually, the value of 0 actually 0? It is. So this would be true. This is a true statement. And whenever we have a true statement, but we're not able to solve for x or y, then it's called all real solutions or all real numbers, right? And we've talked about this before. What type of line are we seeing? It's a line that is overlapping. We can't really draw an overlapping line because every single point on that line is a solution for both of those equations. Okay. Looking at this, can I eliminate? Let's process through what is a good way to eliminate. Well, if I multiply everything by -1 and change this to a +2x, this would become a -5y, and then this would be a -7. Then I can add the 2 and eliminate. So when I eliminate, -2 and 2x cancel, +5y and -5y cancel, and I'm left with nothing equals 5, right? 12 plus -7. 0 does not equal 5. So this is not true. This is false. And then we are going to say a no solution here because anytime you have a false statement, that's what we call no solution. Okay, that's all we have for today. It's really just looking at how to eliminate your equation. So the goal is, what can I do to eliminate one set of variables, either all my x's or all my y's? And you have multiple options. You've got to problem solve and think through what's the best way for you to do it. All right, that's all I have.